Right. I'll remember you people as one of the most patient groups I've ever had. Well done. Let's get to work. Chemistry reactions. Let's go. Right. Let me make sure everything is sorted. Yes, this is perfect. This is perfect as well. Right. I'm a happy man. I'm a very, very happy man. All right. Let's get ready. Here's a crash course going through all reactions. Can you see my screen? All right. So let's write organic reactions. We are finishing them today. We are not going to do reactions again. Organic reactions for all 5 families. All 5 homologous series. Okay? All 5 homologous series. Put these. We're going to do a lot of questions from this. Start. Number 1. Alkanes. For alkanes, you should know 3 reactions. If you want to be safe for alkanes, you should know the 3 reactions of alkanes, which is, am I moving too fast? I'm going to be moving extremely fast. So if I'm too fast, you tell me. I want to move fast. All right, good. For alkanes, 3 reactions. The first one that we must know for all alkanes. We are just doing reactions, okay? Don't worry about everything else. We're just doing reactions. You must know combustion. That is the first one. You must know combustion. That is number 1. You must know combustion of alkanes. And you should just know that when you take an alkane, you learn how to balance the reaction. But just know that when you take an alkane and you react with water, you're going to get and you react with oxygen. Combustion means to burn something. And from now on, everybody, I don't expect you to forget. When you are burning anything, anytime you see a fire, let me make sure that there is no problem here. Okay, good. Anytime you see a fire, students, that means there's combustion going on. And if there's combustion, something will be reacting with oxygen. Something will be reacting with oxygen. So, anytime you're going to see about combustion, it means that thing is reacting with oxygen. So, you must know the reaction between alkane and oxygen. Basically, it will give you carbon dioxide and water. All we will have to do is balance. These are not going to change. Then the second reaction we want to know is going to be substitution reaction. Substitution reaction with halogens. Okay, the substitution reaction between alkanes and halogens. We need to know this one, eh? This is the second one we need to know. Substitution reaction between alkanes and halogens. Let's go. How do you know it? Sorry for the noise. This, what you must know is that it needs UV light. Okay? You have to know that it needs UV light. Okay? Which is sunlight. The sunlight is a source of UV light. And what you must know is, what do you get? Let's go for it. This is the second one, right? It needs UV light. These are just all the reactions. I'm just going to go through all of them as fast as I can, and we'll see how fast it's going to, how long it's going to take us. But this one, you say it needs UV light, and you say it is called a photochemical reaction. It needs light to happen. What are the key things? Hydrogen is replaced by a halogen, a group 7 things. Okay? And in brackets, I want you to say many hydrogens can be replaced. Many can be replaced by halogens. So you can remove a lot of hydrogens and put group 7 things. You remove a hydrogen, you put a bromine. You move it, you put a bromine. You understand? Okay? Students? Are we together? So, all right, good. Now, if you're going to have an example, you put an example of an alkane. We can put methane, CH4, or we can put ethane. Hydrogen, 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 hydrogen reacts with bromine gas in the presence of UV. And what is going to happen is you are going to get a swap. So you have bromine on one of the hydrogens. Like that. Like that. Then you can say plus HBr. Questions? No question. The third one. We've done this and UV light. And can I now say the last and final one you should know is cracking. And it is called catalytic cracking. To form alkenes. Catalytic cracking of alkenes. Okay? This is the last one you must know. Conditions. This has conditions. Conditions for this last and so what you then have is you have large alkane giving us a smaller alkane plus an alkene. And here it will be 600 degrees Celsius to 700 degrees Celsius. And you put alumina or silica. Are we together? Alumina or silica. You can't forget these catalysts for cracking. Are we together, class? We'll do several examples. Yes, we'll do several examples of cracking. Don't worry about it. Here we just want to quickly do the families. The second family, here we've done the first one. We have 5 families to cover. Let's just go through them. I just want to do all reactions to make sure you know. The second one is alkenes. Okay? Remember, what makes alkenes special? Alkenes have a double bond, C double bond C. Okay? And they are more reactive than alkanes. And then their general formula is, okay? The general formula for alkenes. Alkanes don't react. We saw that they only react here with halogens. And in combustion, when you are burning them, and when you react with halogens in the presence of UV and of UV light and catalytic cracking, where you add alumina or silica, then your general formula is CnH2n. Now let's put reaction number 1. We have seen that we must know 3 reactions for alkanes, right? For alkenes, put in brackets to say as well 3 reactions. Can you all hear me? Yes. Number 1. Reaction 1 is reaction with bromine. Reaction with bromine. Water. I want you to put in brackets to say here, used to test for alkenes. It's used to test for alkenes. And what is the test? What you must know is that bromine water which is orange. Bromine water will be orange, or you can say goes through color change. Goes through color change. It will be gone. That's the reason. Orange to colorless. You no longer will have that bromine water. Okay? Okay. Why? It reacts. It reacts to form something else. So you no longer have, you should remember the color changes is orange to colorless. Are you saying this? So alkane, there's the reaction with bromine that goes from orange to colorless. And here's an example. You put your ethene. It meets with bromine. Okay, you can say bromine liquid. What will you have? You are going to have a dibromo. That is the most important thing. 2 bromines, and you have a single chain. You no longer have this double bond. It will break, and you're going to have 2 bromines, and you have your hydrogens like this. And this is what you have. Okay? Please note, all reactions, the three reactions, all are addition reactions. All reactions are addition reactions. Okay? What do you mean? Only one product formed. It's not like alkanes where you get something else. In alkenes, only one product is formed. So here, this is bromination or halogenation. Then here, you can do it with another thing. Then here we're going to have hydrogenation. How they react with hydrogen. We always talk about it. Hydrogenation, which is reaction with hydrogen. Let me summarize to write only small things so that I can put a lot of things fast because I only have 15 minutes left. I want to do everything. Reaction between an alkene and hydrogen. Okay? Okay. Can I move on? Can you all still see my screen? Hello? Can you all still see my screen? Okay. Right. Now, right here to say, this hydrogenation produces an alkane. Okay? And I want you to say, needs nickel catalyst. Needs nickel catalyst. So you're going to say, example. Here's your alkane, I mean, plus hydrogen gas. Then you form one product. Don't you forget. An alkane. All of you, I'm so happy. I'm proud of all of you. Trust me, guys. I'm really, really proud. Remember, you need nickel catalyst. Let's go to the last and final one. Third reaction for alkenes is hydration, which is reaction with steam. The third and final reaction for alkenes is hydration, the reaction with steam. You put it like this. Let me just write some points here to say this one, it produces an alcohol. And I want you to say it needs, or let me say conditions. Conditions, you need 300 degrees Celsius. You need 60 atmospheres of pressure. You need phosphoric acid catalyst. Phosphoric acid as the catalyst. And phosphoric acid is H3PO4. I'll show you some important acids that you must know. Phosphoric acid is one of them. Then hydrochloric acid, then sulfuric acid. You should know them. H2SO4 for sulfuric acid, HCl, hydrochloric acid, HNO3. So here are the acids that you must know. HCl, HNO3, H2SO4, H3PO4. Hydrochloric acid, nitric acid, sulfuric acid, phosphoric acid. When you say the acid, the only one you say hydro is the first one here. The other ones, when you say their names, you ignore the H, you start here. Nitric acid, sulfuric acid, phosphoric acid. Right. Are we together? These acids you must know. Phosphoric acid is the acid which you can use here, but you can just use any acid, an acid catalyst. But just say phosphoric acid. These are the conditions to produce an alcohol, the third and final reaction for alkenes. Can you all hear me? Can you all hear me? All right, so this is going to be it. So let's put an example. This is just an example. It's not the only alkene you get. You can get any alkene. But once you see an alkene at 300 degrees Celsius, 60 atmospheres, phosphoric acid catalyst, alcohol time, alcohol time, alcohol time, reacting with water, reaction with steam, which is H2O gas. Alcohol time, alcohol time. So just do it like this. Reacts with water, the third bond, which will be an OH bond. This one will be gone. The double bond. The double bond negotiating, we are telling you. Right, let's go now. Alcohols again. 3 reactions again to know. 3 reactions, yes. Right. Okay. Where is it? Can you put for me to say alcohol's 3 reactions? Then I'm going to show you the deadliness of this. Right. Let's start with the first one. For alcohols, right? Production of alcohol, right? Production. Fermentation. This is the production of alcohol. And there is something tricky about production of alcohol is that you are going to need to know 2 methods. They say the production of ethanol. Ethanol is an alcohol. Are we together? And we're going to be comparing hydration of an alkene to fermentation. Are we together? We've already seen that if you add if you have an alkene, and you have your 300 degrees Celsius, you have your 60 atmospheres. Alkene, you have 60 atmospheres. You have phosphoric acid, you have 300 degrees Celsius. You cannot forget these simple conditions. We say that you're going to get an alcohol. If you add steam to an alkene, so that's hydration, because you're adding water in any form. That's hydration. Now, we have a second method, which is fermentation. Okay? Production. So can you put it? Fermentation. And for them, they are going to be producing ethanol. That's the alcohol you're going to do at IGCSE. Okay? Are we together? So how do you produce it? You take your glucose, C6H12O or 6, you are going to ferment it, and it is going to form carbon dioxide plus your alkene. And it will be 2 of each, 2 of carbon dioxide, 2 of the alkene. This is fermentation. What you need here is yeast. So let's put, and then you need 25 to 35 degrees Celsius. This is just room temperature almost. 25 degrees Celsius is room temperature. So what are the requirements? Conditions. It should be at room temperature. Okay, make sure it is at room temperature, and make sure that there is no oxygen. There is no oxygen. Make sure that you have 25 degrees Celsius to 35 degrees Celsius. So you close out oxygen. There mustn't be oxygen. And we need yeast. If you add them to your glucose, then you are going to form ethanol. Are we together? Yes. This is ethanol again here. Here you formed ethanol as well. So it's production method number 1. So I'm not going to talk about it since you've already talked about it. Right? But now what you should now do is you should compare. Okay? After knowing this, you should compare. So comparing the 2 alcohol production methods. Okay? And when they say alcohol, they will be using the word ethanol at IGCSE. Are we together, class? They'll say comparing the 2 ethanol production methods. It's just alcohols, but they are working with ethanol as an example. Right, let's compare them. We're going to talk about the things that make them different. So feature, then here we'll say hydration of alkene. So the 2 alcohol production methods, what are they? The 2 alcohol production method: hydration of an alkene. But you will be dealing with ethene, because you are going to be producing ethanol as the alcohol. Okay? But basically we are comparing hydration of alkene to fermentation. To fermentation, where you add yeast, and the thing that makes them drunk in all those things is ethanol. So when we say alcohol production, it's also the alcohol that people drink, this ethanol. Are we together? If there is no, and it's fermentation like you see them doing for wine and everything. They have to ferment it, close it off, put it somewhere where there is no sun. So put it somewhere where there is no oxygen and all those things. So fermentation is the second one. Okay, fermentation of glucose. Are we together? So let's now see the methods. So here we're going to say feature. We want to see where they are different, because the syllabus wants you to know. Okay, this is 1. Then number 2 is fermentation of glucose. Are we together, class? Can you see this? So say feature. Then I want you to say here what happens when it's hydration of ethene and alkene, right? Then what happens when it's fermentation of glucose? Can you all hear me? Fermentation of glucose. The syllabus expects you to know this. So put on fermentation of glucose. Yes. Let's put feature number 1. The first thing we should know, which is going to be different between them, is the raw material. So number 1 is raw material. What you use to produce. Right. What are we going to use in hydration of alkene? We are going to use ethene. And ethene is going to come from crude oil. Ethene comes from crude oil, which is a non-renewable source. Okay? Crude oil is not renewable. Fermentation comes from sugar, which you can just grow more. So this is renewable source. So that's point number 1. Then number 2, the other thing which makes them different is that is the speed of production. Speed of production of your ethanol. When you do hydration of an alkene, it's going to be fast. Okay? This is going to be slow. It takes some days, a matter of days, to produce the ethanol. It's very slow. Then, here, the process. In here, it is going to be continuous. Then the in here is going to be a batch process. You like what we're saying is this. When you can't keep adding. Is there a way for you to keep adding glucose, class? Is there a way for you to keep adding glucose? Let's say more alcohol is produced. You are continuously collecting and adding more glucose. Is there a way? No, there is no way. Why is there no way? Because remember, we are closing it out, so we can't open it, then keep adding. So it's like you make some alcohol, then you are going to open, take that alcohol, then you ferment again. So this is a batch process because you are fermenting. You are closing it out, okay? So this container is closed for fermentation. For fermentation, there should be no oxygen. So we have to close it out. So when you open it, that means fermentation will not keep happening. But for an alkene, you can keep pouring this ethene and you can keep reacting it with your steam and you will keep producing your ethanol. Are we together? Now, the fourth thing is going to be the conditions. The conditions. Here we saw that this needs a very high temperature. This is high temp and a high pressure. Okay? Because it needed, you remember? From an alkene, what did we need? Class, to produce, we needed 300 degrees Celsius. And we needed 60 atmospheres, right? Is it not true? That's a high temperature and a high pressure. But when we look at this other method of production, it just needs a low temperature. That's room temperature, which was 25 degrees Celsius to 35 degrees Celsius. Is it not, class? It is, right? So the conditions for here are different. Now, number 5. The purity of ethanol produced. That's the other thing which is different about these. The syllabus wants you to know this. Yes, it wants you to know it. What? Are you telling me? Yes. Oh, are you not wasting my time? No, I'm not. This produces pure. Okay. This one produces pure ethanol. This one produces a dilute version. It has water in it, which will need some distillation. It needs distillation to then separate. Distillation is a way of separating different substances using their boiling points. So you are separating liquids by using the fact that liquids have different boiling points. So different liquids have different boiling points. If you use boiling points to separate things, you are doing distillation. That's what distillation is. I don't want to hear anything else. When you talk about distillation, you are just boiling those things. So you know that one will boil before the other and turn into gas. When you boil, it means you are turning into gas. That's why you see bubbles. It's the whole thing is turning into gas. The whole liquid is turning into gas, escaping like that. So when you boil things, one will turn into gas before the other, and it boils, it flies away. You are going to collect it somewhere else. You condense it, you collect, and that is how you do it before the other one has boiled. So distillation, you will need distillation to separate these two liquids. How do we do it? Because they have different boiling points. So the dilute version of ethanol you will need to distill it. Then number 6. Now here let's see what makes this method of fermentation good for some people. It is the energy used. The energy used in this. It uses a high amount of energy. high amount of energy to heat until you get to 300 degrees Celsius, and to keep something at 300 degrees Celsius, you are using a lot of energy there, man. I'm telling you. Here, low amount of energy used to keep it at 25 to 35 degrees Celsius. Very little amount of energy used there. Or let's say here, the 7, the environmental damage. Environment. This one uses fossil fuels. So of course there's damage there. And it causes global warming. This one also, it also produces carbon dioxide. Fermentation, if you sow, carbon dioxide is one of the products of this thing. So anyway, it also produces some carbon dioxide, but here it uses fossil fuels, which produce a lot of greenhouse gases besides the carbon dioxide. There's more. Okay, so remember to give, when you're answering in an exam, remember to give. Let me write it here. I want to show you how to use this table, the things that I've said in this table, because you're going to use some points there, right? Here, how to answer in an exam, how to compare the two methods in an exam. Always give, let me say, paired points. Always give paired points. Let me show you an example. Here's an example of what I mean by always tell us both sides of the story. Here's an example. Hydration is faster, as the hydration of an alkene. Hydration is faster, but uses non-renewable resources. Okay, it uses, you can say non-renewable resources, or you can say it uses fossil fuels that are non-renewable. So you've talked about its benefit and its disadvantage. While fermentation is slower, yes, it is slower, but uses renewable resources. You can plant more sugarcane or whatever the sources. Are we together? Hello? Now, let's talk about the last one. The last reactions that you must know. Oh, wait, what did I tell you right now? I just told you alcohols, right? Now, there's the third thing that you must know about alcohols. So, let me say, in the reactions, one was this one, and this is second reaction to know. It is a production reaction. So when you do alcohols, you must know how they are produced. That's two reactions already. Fermentation, which is this one, you should put this, and this one, which is hydration of an alkene. Then finally, you must know the third and final reaction of alcohols. After doing all this and comparing, you should know the third and final reaction of alcohols. That is oxidation of alcohols. You have to know oxidation of alcohols. Okay? And say, forms a carboxylic acid. Okay? So you must all know the oxidation of alcohols, and that they form carboxylic acid. So you can say alcohol, when you oxidize, so when it goes through oxidation, you are going to get a carboxylic acid. Now, let me say this: when you are doing your oxidation, you are going to oxidize it using acidified, you say, sometimes we say H plus, but you can say acidified KMnO4. This is potassium permanganate. Then you say heat. So you say acidified potassium permanganate and you heat it. You're going to get an acid. You're going to get a carboxylic acid. Are we together? So, yes. Here's how they can show it sometimes. They can just say C2H5. Example, they can say you have your ethanol, C2H5OH, and they can put it like this to just say oxidizing agent. Okay? This means oxidizing agent. Okay? Oxidizing agent. E.g. KMnO4. Right? You will get carboxylic acid, which is CH3COOH plus. So there were two carbons. You separate them. You remember, when you are making a carboxylic acid, take one carbon from here and put it at the end to be a COOH. And you remain with the CH3. Then now you show plus water. Okay? So you get carboxylic acid plus water. You should always show that. Are we together? As the last reaction. Are we all together here? Now the last group. Okay? If you know this group, then you are fine with esters. If you know this group, then you are fine with esters. But we can just do esters on their own. Let's say carboxylic acids. This is your group number 4. Okay? I just want to finish so that tomorrow we just do this together. Carboxylic acids. You've already seen how they are formed. You've already seen how they are formed, right? So now let's do their own 3 reactions. Let's do their own 3 reactions here. Are you ready? Number 1, where it will be for our 4 reactions of these, you just show metal plus hydrogen. This one, you understand? You just do the reactions of acids. So acid plus metal. This is the very first. They react with metals. And they are going to give you salt plus hydrogen. We'll go back to the topic of metals later, and acids and bases. But acid plus metal gives you salt plus hydrogen. So you're going to put your carboxylic acid. Let's put it. Example. Put your carboxylic acid, CH3COOH. And you put 2 of them. Reacts with magnesium. What just happens is just this. You remove the hydrogen, you put magnesium. So that's very easy. So it's going to be, you say CH3COO. The reason why I put 2 of them is that magnesium is in group 2. If it was sodium, then you didn't need 2. Should I put, let me use sodium so that I don't use. So it'll be CH3COO, then you say Na like this. Then you can now say plus hydrogen. So now you'd put hydrogen like this. For us to have 2 hydrogens, we'll say 2 of these, 2 of these, 2 of these, so that we'll get 2 hydrogens being removed. Because each Na will remove 1 hydrogen. We want to remove 2 so that we get hydrogen like this. Hydrogen is always in 2s. So that is why we are going to use 2, 2, 2, 2, 2. So that we end up having hydrogen in 2s. Because anything that ends with gen, hydrogen, nitrogen, oxygen, these guys are always in 2s. And anything that ends with in, fluorine, chlorine, bromine is always in 2s. All right, now we do the second one, okay, which is going to be acid plus base. So you take this carboxylic acid to get a base. You get salt again. Salt all the time. Yes. Anytime you do. So there are 3 reactions to know for carboxylic acids. Yes. And all of them are going to produce a salt. Yes. What is a salt, sir? What is a salt? Is it something we eat? No. A salt in chem means you have a metal with non-metals, an ionic compound, basically. That's a salt. So this metal should put itself somewhere in here so that we get a salt, or else we have failed. So acid plus base, you get salt plus water. Now, oh really? Yes. Let's put an example. Okay, you don't have to know any conditions, but you should just know what you get in case they ask you. You get CH3. Remember, in your exam, they will do this. They will just give you an acid. You should recognize it's an acid. And you should when it's reacting with a base, it will be hydroxides. Your bases are the hydroxides. Hydroxides are the bases. So acid plus base, just say hydroxide here, please. Hydroxide. Sometimes they can show an oxide as a base, but mostly hydroxides. Okay? Hydroxide, that's what we mean by base. Like here, sodium hydroxide. This is a base. What do we expect? We expect the sodium to remove the hydrogen. So you are going to have CH3COONA. The sodium has removed the hydrogen to get a salt. Then the hydrogen will go to the OH and you end up getting water. So it will be H here meeting with this OH. You get 2 hydrogens, H2, and this 1 oxygen. So that's water, H2O. Anyone with a question? Then the third and final reaction of acids. You cannot afford to forget this class. We can't afford to. Acid plus carbonate. If it now meets a carbonate, then it is going to form a salt again. Really? Yes. But it will now form water and carbon dioxide. So here it used to be salt and water only, but here it will be salt and water and carbon dioxide because of the carbonate. Let's put an example. So this is, what acid are you talking about? The carboxylic acid. Really? Yes, because it's an acid. So CH3COOH, you can put 2 of them. It reacts with, let's just say, sodium carbonate. This is how it is, Na2CO3. The moment you see CO3 with a metal, that's a carbonate. So you see this, wake up, you're dealing with a carbonate. What you do, take this metal away. If it's a carbonate, just take away the metal, put it where there is hydrogen, and remove the hydrogen. So we are going to have it forming 2 moles of CH3COONA, because we have 2 of them, because we had 2 NAs. Then we are going to say plus water plus carbon dioxide. Am I done? Yep. And remember, tip. All salts. So this is a salt. This is a salt. This is a salt. For carboxylic acid, you always make a salt. So you should know that it will always end with anoate. So all salts start will be like this. Will be metal. Okay. Then you're going to put the organic name. Then you're going to end with anoate. So it will be organic first name. I want you to say the organic first name. What is this one? Let's put an example. This one. It is going to be, what metal is there? When you are naming them, you start with the metal. What metal is there? Sodium. Then, what do we say? How many carbons are there? 2. So it will be eth. Then you say anoate. So it's sodium ethanoate. Because when you have 2 carbons, the first name is eth. So it's sodium eth, then you say anoate. So sodium ethanoate. Are we together? Then you should always, to prove that it has reacted with a carbonate, you should do the carbon dioxide test, CO2 test. Okay? To show that carbon dioxide is being produced, you see bubbles. If you see bubbles, you know that carbon dioxide is being produced. And those bubbles, they turn lime water milky. They turn lime water milky. Are we together? Last thing. Esters, you need to know one reaction. Only? Yes. Only one reaction, sir? Yes. So you people are not letting me down. There's not much here. Only one reaction? Yes. You're going to say one reaction, which is what is the one reaction? Esterification. What is it? It's going to be carboxylic acid plus alcohol forming, it's a reversible reaction to form ester plus water. Conditions: you need concentrated sulfuric acid and you need heat. So if we say conditions, you can put conditions to say you need concentrated sulfuric acid and you need to heat. So it's your turn to now go and write these reactions from your own head. If I can, then you can. Let's put an example of this one reaction which we must know. CH3COOH. This is going to be ethanoic acid. I'll make it react with ethanol. Ethanol is the common. Oh, yes, ethanol is the common alcohol, so why should I not use it? But no, let me make it react with propanol. Why? Why did I choose propanol? For the name, so that I show you something about the names. And what are you going to get, class? Here's what you're going to get. You're going to take the side of the carboxylic acid, you put it first. CH3, then you say CO. This OH will go. Okay? Then here you just remove the H. So you will now put, after CO, you put this O, then you put this. So you're going to put O, then you say C3H7. Serious, sir? Yes, then you put plus H2O. Don't let me down. You can watch it again. I said, remove OH on your acid. Remove H on your alcohol. Then when you're now putting them together, you put the acid ending at the O before OH. Then you start with this O. Then you put this. So it ends at the O. You start with the O. Then you put this. This is where the ester linkage is here. Anyway, we now say, what is the name of this guy? I want you to remember this. Don't ever let me down. The alcohol thing part always is the EO. So let me say for the name, it is alcohol part is going to be the one which ends with the EO. Then the carboxylic part is the last part because it's the stronger one. Carboxylic acid part, although you may write it first, but it should always be the last one, and it should be the one which ends with anoate. So basically, I'll go and check what carboxylic acid did I have. I had ethanoic acid, so that means it's going to end with ethanoate. Then here I had 3 carbons, so it was a propanol, so it's going to be propyl ethanoate. So this, if we do this, it ends with il, this ends with anoate. What should we have? We should have this being propyl ethanoate. Yes. Is that true? Yep. Propyl from the name of the alcohol. Okay. Then anoate from the name of the carboxylic acid. Okay. And always remember that water is going to be released there. Thank you. So 1 reaction for esters, 3 reactions for carboxylic acid, 3 reactions for alcohols, 3 reactions for alkenes, 3 reactions for alkanes. So you are not going to let me down here. You should write them down with their conditions, with what they need. This is the one with the highest temperature in the whole of your organic chem. Catalytic cracking. You remember it needs alumina or silica as your catalyst. This is a cheat code, and I'm going to send it to you as a PDF. Cheat code, 1-page summary sheet of all reactions. Are we together? Is this hard? No, sir. Thank you. Thank you, students. We meet tomorrow, and we do this as a blast together. We are going to do a lot of questions, group by group by group. We need to make organic chem easy. We can't keep tolerating this. And there's one part I need to teach you about polymerization. Then I feel like I'm good. And I'll be teaching you the other things as I do a lot of questions. So I'll do one day when I just go through questions from maybe 2018 all the way to 2022. Then I'll give you the other ones as yours now. So those who have not yet submitted my assignment, please, respectfully, just submit my assignment tonight. Don't make me look for you, okay? Just submit my maths, and I want to see how you're writing. That's exactly why I'm giving you assignments. I want to assess. I want to see how you're writing. So if any of your parents say, sir, my daughter is doing this, I want this from my daughter, I will have my opinion. Okay? I will have my opinion on all of you. So if something is, oh, I want my daughter to do this, if your school comes this time as you're registering and puts pressure on you, you should write core or you should do this, I will have my opinion, because I will be knowing all of you as my students. So please submit my work. I use it very much. I always look at how you guys are writing. It's something which I take very, very important. I need it. It's feedback for me as I teach, to know where to do, where to change, where to do. So please make it easy for me. You are a very good class. Just submit work. If it's hard, do it. I want to see that so that I know how to help you. So don't be afraid. No one will know your marks. They are mine and yours. So we will be knowing them together, and your parents. So don't be scared of me. I'm your best friend by far. Goodbye, students. Good night.